There are so many materials in dentistry. When you're a patient that finally decided you want to replace all your teeth, how do you decide on which material is best? There's all these different labs and providers out there trying to tout these new materials that are better than the long-standing materials that have been used for many years. I'm Nick Hansen. Today we're going to get to the point on different dental materials. There's people on the internet that are showing experiments to try to show how strong their teeth are. But what is the purpose of dropping teeth off of a building? I don't know, but it looks like fun, so we're gonna do that today as well. We're gonna drop it from different points and see what happens. All these different experiments that we see online are usually to show that zirconia is gonna break and their nanoceramic's not gonna break. But we need to talk a little bit more about that, why zirconia breaks, and should it matter if you can drop it off the building? What is the most important attribute that we need to look at when we look at our strength of our teeth that we're making? That's going to be flexural strength, and that is going to give us the strength from flexing the teeth. And the wear and tear and the grinding and everything, it's going to be the bend that we get in the teeth, not dropping it from a 40-foot building. So flexural strength is measured with these different prostheses in megapascals. And the megapascals for zirconia teeth are going to be over 1,000 megapascals. That's the strength of these teeth. And when we look at ours, for instance, when we use alien milling, for instance, we have many different pucks, but this is a box I went and grabbed off the shelf. And if we look right there, it's 1,200 megapascals in this puck. So this is very, very strong. And if you were to try to break it with your hands, you're gonna have a very hard time doing that. Now, with these other prostheses, with the nanoceramics and these acrylics, they're gonna range from 200 to 400-ish megapascals. So the flexural strength of these different prostheses are never going to be anywhere near zirconia. There's a lot of materials that are coming out, and I'm excited to see what happens to different materials in the future. But right now, the strongest material is zirconia. And people are going to show you that they can drop other ones off the building, but that has more to do with the weight of the zirconia versus the weight of the nanoceramic. And I'm going to actually weigh these two different prostheses, and you can see how much the weight difference is, which is going to affect the force that it hits the ground with. All right, we're going to weigh some zirconia teeth on our little scale here. We get 2.4 ounces. And the nanoceramic comes in at 0.8 ounces. The zirconia came in at 2.4 ounces and the nanoceramic came in at 0.8 ounces. So the zirconia weighs 3 times as much as the nanoceramic. And the zirconia is actually a lot smaller prosthesis and actually doesn't have the cylinders in. So here's a smaller prosthesis. Let's see how much this one weighs. So that would be 1.4 ounces for a nice zirconia arch. All right, so 1.4 ounces is an almost empty water bottle. There's a tiny bit in there. The 16.9 ounce water bottle with very little water in the bottom weighs 1.4 ounces. So that's the equivalent of a zirconia arch. So if you couldn't imagine having every tooth filled with every surface, which would be 28 teeth in most people, that would be the equivalent of the weight of this zirconia arch. Now, how do we put that more in perspective? This water bottle with a little bit of water weighs the same amount as this zirconia arch. So they're both 1.4 ounces. So it's not extremely heavy at all. As we know, this little water bottle does not weigh very much. So why are we trying to make something that's lighter than what our natural teeth weigh? Everybody always talks about zirconia being so heavy, but why are we trying to get something that's super light? Because our natural teeth have weight to them as well. And people have gold crowns and fillings and things like that that are going to make them weigh even more. 2.4 ounces to 1.4 ounces, which is what I'm holding right here, isn't going to make a big difference when you're talking about the force of your jaw. All right, I'm here with our operations manager, John. He does a lot of research on different materials, and we've seen a lot of these things coming on the internet that's showing people dropping prostheses off the roof with like nanoceramic, but saying that zirconia is going to break. And we're sitting here with the tile of our floor, which is actually not tile, it's concrete, and we're going to drop the zirconia prosthesis on the concrete. And this is John, our operations manager here. And we've got a prosthesis that he's gonna drop here on the floor. All right, John, whenever you're ready.
Ready?
Yep. All right, so let's see. Didn't break. So let's go out to the concrete, since people are dropping it off roofs on concrete, and let's try to drop it on the concrete. Now we're outside on the concrete. We'll show that we can drop it on the concrete as well.
Ready?
Yep. All right, didn't break. Should we go up a little higher? Should we go up a little higher?
Sure.
All right, let's go up a little higher. A little bit of height. Whenever you're ready, John. That one took some bounces. Ready? Go. John's up there. He's ready to go. He's might be calling me right now. Hang on. Let's see what he's saying. All right, John. We're up 4 stories. Let's do this. You ready?
Yep.
Whoa, that went into a lot of pieces. All right, this is another one of those things I see on YouTube, and we're just gonna show driving over the prosthesis. Go ahead and go forward. All right, and there it is. Still fun. So we dropped it on a concrete floor from about 5 feet, and then we went and we dropped it from about 12 feet on the concrete sidewalk outside. And then we want to take it a step further, and we dropped it a few times on that concrete, but we want to take it a step further and drop it from about 40 to 50 feet in the air. And so we dropped it on a concrete sidewalk, and it did break, right? So did we expect it to break? Yes, we went into this, we didn't think it would actually last just on the concrete. We thought it would break from the 12 feet. We were surprised that it actually didn't break dropping from 12 feet. But we dropped it, a dozen times before dropping it from the 40 to 50 feet foot building. And that's when it finally broke. My background's in engineering, but I haven't done engineering in a really long time. So I had to dust off the old equation books and make sense of what this means and figure out the force that was hitting the ground when these prostheses are dropped on the ground. So let's start with acceleration. Acceleration is going to be the same regardless of what we drop off of the building. And that's going to be 32 feet per second squared. That is the equation for gravity. So to calculate the energy that's dissipated when these prostheses hit the ground, you would calculate energy by calculating 1/2 times the mass of the prosthesis times the velocity squared. Now we want to look at velocity squared to see, is there anything in there that's going to change based on each prosthesis? And the definition for velocity squared is 2 times acceleration times the distance. So 2 times the acceleration times the distance. Acceleration, that's constant. The distance, it's constant because we're dropping it from the same height. So we know that that's going to stay the same. So the only thing that's going to change in this energy equation is going to be the mass. And we already know that the prosthesis of the zirconia is significantly heavier than the prosthesis of the nanoceramic. That's why when you have an impact from a very high distance, it's multiplied by, well, in this case, 3 times because it weighs so much more. Does it matter that the zirconia weighs more than the nanoceramic? Well, not in everyday use. That doesn't matter at all. It only matters when we're trying to calculate the energy that is dissipated when we drop it off a building, because you're not going to have gravity forcing a collision with these zirconia teeth unless you jump off a building, which we don't recommend. So when you're chewing, you're using the force of your jaw. That's independent of what gravity is. And so we're not worried about jumping off a building or throwing these teeth off of a building because that's reliant on gravity. So it's all about the force and flexural strength. And so we want to make sure that we have a prosthesis that's going to withstand the flexing of everyday use of these teeth, not the impact from gravity. I'm very excited about the future of different dental materials that are coming out. There's hundreds of them out there. We're always experimenting with new dental materials. There's nothing out there right now that's going to be as strong as zirconia. Zirconia is the strongest material for dental right now. It's the hardest to work on though. Because it's so strong and durable, it's very hard to work on. You have to be very, very precise and very accurate. And if you're not, you can't really make a lot of adjustments to it like you can with all these other materials. These other materials are great. They're a lot cheaper and they're easier to work on. And so we do see a lot of future in that. But for longevity, zirconia is going to be the best option. Make sure you don't get fooled by these different experiments out there to try to persuade you that something's better than another. You always got to look at what is actually going to affect everyday life. Is throwing a prosthesis off a 40-foot building going to be equivalent to anything that you're doing in everyday life? Not typically. Dropping it from a 12-foot ledge, that's not normal either. You're going to break your natural teeth when something like that happens. So what is more normal? I mean, we ran over the teeth today with a car. Is that normal? Not really either, but that's closer to reality because we're showing the flexural strength because we're running over it. We're showing the bend that we can get in the teeth. Whereas, a huge impact from a throw off of a building is not normal. But even then, we ran over it with a 3,500 pound car. That's divided out amongst 4 wheels. Is that real or not? Probably not. But it shows the strength of it. I've seen that experiment before, so we just wanted to do it while we were out there. I'm Nick Hansen. I hope you enjoyed this video. And today we got to the point on zirconia strength.